Hi everybody and welcome to session 10 of Field 2002 Logic, How to Defeat Your Foes with Reasoning. In the previous session I was talking to you about monadic predicate logic. Monadic predicate logic is an extension of propositional logic that adds new kinds of syntactic items, new symbols that enable us to represent a broader range of propositions and a broader range of arguments. And what we did was we produced a set of syntactic rules or grammatical rules for the language, monadic predicate logic, that enabled us to work out how exactly to apply these new symbols and how it is that we can work out what is syntactically or grammatically well formed in the context of this new language. So just to remind you of the new symbols that we added first of all, names which were lowercase letters. So we added A, B, C, and so on up to the lowercase letter s, and these names are picking out particular objects in the world. Then we added variables, x, y, z, and those variables enable us to talk about things without having to name them. After that we added predicate letters, and predicate letters are these capital letters that have a slot following them in which you can either drop a name or a variable. And then we had the universal quantifier, and the universal quantifier enables us to talk about a range of things without having to specify them by name, and it also allows us to talk about a range of things that might have certain properties or the relationships between different things that have different properties. The key to the universal quantifier though is that it ranges over everything. Finally, we had the existential quantifier, which is just talking about something. So when the universal says for everything and then goes on to specify some features or conditions under which everything is held, the existential quantifier just talks about something, at least one thing. And then it goes on to talk about that one thing. So you might say, there is a rich person in the room, and in order to say that, you'll take the existential quantifier and then predicates for rich and person and being in the room and use the existential quantifier to translate out that sentence. Okay, so this is our new language. In addition to these extra items, we also have our old friends, the conjunction, the disjunction, the negation, the conditional, and the biconditional. What we can do is we can combine all of these things to produce sentences that enable us to translate out complex English claims. And that's what I'm going to do at the start of this lecture. I'm going to take a range of examples and show you how to actually apply these symbols in order to translate out aspects of the language into monadic predicate logic. After that, I'm going to tell you three important things about how monadic predicate logic works and how the translations work to give you a better sense of how you can go about completing these kinds of translations. In the next session, we'll move away from the syntax and start to interpret this new language that we have. Interpreting the new language involves applying a semantics to the language, which is what we did with propositional logic, except that the semantics that we use for this new logic, which is called monadic predicate logic, is a different semantics that we used for the propositional logic. And what's very important here is that truth tables, which we could use in the propositional logic case, can no longer be used with respect to monadic predicate logic. So sort of from here on out, we're not going to be thinking in terms of truth tables any longer, except insofar as we have to reapply these objects. So those truth table definitions will to some extent still apply for these things, but the global semantics, the broad semantics that we're using, is not going to be stated in the same sort of truth table terms that the propositional logic semantics was stated. Okay, so let's have a look at some of these examples. We've got some sentences in English. All of these sentences involve the quantifiers, and I'm focusing on these because they're the hard things to translate out. So we've got everyone is sailing unless someone isn't, everyone who is not sailing is not juggling, everyone juggles just in case they are coordinated. If someone is juggling, then everyone is watching, everything is either black or red. If everything is either black or red, then something is blue. So let's take each of these one by one and perform a translation into our new monadic predicate logic. I'll take this very slowly. We can break each sentence down part by part until we've got a full-blown translation into the language. Okay, so let's start with this first sentence. Everyone is sailing. We've got the sentence up here. Everyone is sailing. So there's our sentence. Now we've got to look at the moving parts that we have in this sentence. First of all, notice we've got this every. And that every clues us into the fact that we're going to be using a universal quantifier in order to translate out this sentence. So we're going to put that in first. Okay? Now what else do we have? Well, notice we've got the property of sailing. So this is a property that certain things have. Boats have it, maybe people have it when they're on boats, maybe birds have it when they're sailing through the air. Various things have it. What we're going to do is we're going to introduce a new predicate for the property of sailing. Are we done? Well, not quite, because we've got two other things to do. First of all, we've got to find some way to say that everyone is sailing. So we've got to have some way of linking the universal quantifier up to this predicate of sailing over here. But also, we've got to keep in mind that we have to translate out this one in the statement everyone. So that everyone, what that's actually doing is disguising two moving parts. On the one hand, the every, the universal quantifier, but on the other hand, a property of being a person. We're actually talking about people here when we use the statement everyone, and so we've got to add a predicate in order to represent that. So let's do that now. We're going to add the property P, which represents X as a person. Okay, now, with the universal quantifier, we've always got brackets following the universal quantifier, which represent the scope of the universal quantifier. I'll say a bit more about scope later on in the lecture, but the basic idea is that whatever's in the scope of the quantifier is everything that that quantifier applies to. So if we've got this universal X here, that X is going to connect to all of the X's that are within the scope of the quantifier, so long as they're not connected to some other quantifier, and I'll explain that a little bit later on. For now, we'll just focus on the fact that we've got this X in the universal out the front, we've got these brackets around our P and our S, and so that universal quantifier is governing everything that's within those brackets, which is what we want, because we want the sentence everyone is sailing to be fully in the service of this universal quantifier, which means that that universal quantifier has got to be right out the front, governing the entire proposition. Okay, so now we've got to add something else. We've got to connect this universal, this property of being a person, and this property of sailing together using some other feature of the language. What other feature are we looking for? Well, we're going to be looking at our propositional logic connectives, which enable us to connect some of the different moving parts of the monadic predicate logic. So in particular, we've got to put something in here, something that connects the P and the S, and in virtue of doing that, also makes the universal connect the whole thing together. So what we want to say is everyone is sailing. The way that we translate out this kind of claim is to say something like the following. For all things, if they're per people, then they're sailing. So we use that conditional structure. Why do we use the conditional structure? Well, look at the sentence. Everyone is sailing. What are we trying to say here? We're trying to say that for everything, if it has the property of being a person, then it has the property of sailing. So for all people, they are sailing. In order to do that, we're specifying a relationship, a conditional relationship between these two properties, all within the scope of the universal quantifier. So to translate this out, all we have to do is add in an arrow into the brackets beyond the universal quantifier, and we end up with a statement that expresses this English sentence, everyone is sailing. So this is how we translate out that sentence, everyone is sailing. For all things, if they're people, then they're sailing. I know that that can seem a little bit strange when you first translate it out, to sort of take a sentence like everyone is sailing and then translate it out to for all X, if X is a person, then it's sailing. It can seem sort of artificial and odd. But what we're actually doing here is we're breaking apart the logical structure of the English. The English is a sort of very compacted way of expressing the logical thing that we're trying to state. And so when we draw this out, we're kind of drawing out the full-blown logical structure of the sentence. That's why it feels a little bit artificial, because the logical structure of the sentence is sort of taking away some of the elegance of the English sentence, which is disguising some of that logical structure for us. All right, let's look at another example. Everyone is sailing unless someone isn't. Now remember what I told you about unless? The rule of thumb with unless is to translate it out as a disjunction first, and then if you want to get the conditional forms, you can move from the disjunctive form into the conditional forms. We're just going to focus on the disjunctive form. We don't need to focus too much on the conditional forms. Although if you want to have a look at the conditional forms, I recommend having a look at the earlier lectures towards the start of the course when I first introduced translations in propositional logic and told you how to handle unless. Everyone is sailing unless someone isn't. So let's have a look at that. I'll put the sentence up again. Everyone is sailing unless someone isn't. So let's break it down. What are the moving parts of this sentence? Well, just as with the previous sentence, we had that universal quantifier in there, so too do we have a universal quantifier here. We've got that for all sitting right at the start of the sentence. So we know that we're going to have a universal quantifier in here somewhere. What else do we have? Well, we've got this sum here. And when we see a sum or a someone or a something or something along those lines, what we're going to do is we're going to see that as an existential quantification. We're saying there's something that isn't the case or someone that doesn't have a certain property. And so in this case, we're going to read that as an existential quantifier. We have to be sometimes careful about this. Sometimes our everyone's actually are best represented using existentials. Now someone's are best represented using universals. And we'll get a better sense of that once we have the semantics in hand. That'll enable us to do translation in a more careful manner. But just at the moment when we're dealing with these basic sentences, we're just going to use the rule of thumb that when we see a sum, we're going to translate that out using the existential quantifier. So we're going to have this existential in there. Now what's very important here is that when we have multiple quantifiers, we try and use different variables for the scope of the quantifier. Actually, we don't have to do this, and it's something that I'll talk about at the end of the lecture. But in order to avoid ambiguity, in order to make things as clear and as conspicuous as possible, we're going to use a different variable every time we introduce a distinct quantifier. So because we've got this second quantifier in here, we've already used x, we're going to use y. Okay, now what else do we have in the sentence? Well, we've got this sailing again, so we're going to have the predicate s. And now following that, we're going to have some variable following it. Depending on whether it's relating to the universal quantifier or the existential quantifier, that variable might change. So we're either going to have an x falling in there or a y falling in there. We'll leave that slot open for the moment until we decide what exactly to do with it. What else do we have? Well, just as in the previous sentence we had the everyone, we've also got the someone and everyone here. So in this case, we're going to have people kicking around in our sentence somewhere, so we're going to have a property for them. I'm going to put that in. Again though, we don't know what variable that's going to have following it because the everyone up here is going to be in the service of the universal quantifier, so we might want to have an x there, and the someone down here is going to be in the service of the existential quantifier, and so we might want to have a y. So just for now, we're just going to leave it open as to whether we've got an x or a y dealing with it. Okay, so these are all the moving parts that we have with respect to the new aspects of the language. Finally, we've got to look to see if there's any old aspect, anything from propositional logic that we need to translate out, and it looks like we have something there, namely this unless. So we're going to treat that as the disjunction, as I mentioned before, and so we're going to add that into the mix. I'll put that here. Is that all we have? Well, there's something else we have. Notice down here we've got this isn't. Up here we've got an is, down here we've got an isn't. That is not is something that we're going to have to represent, and the way we do that is by introducing one of the old things that we had from propositional logic, namely the negation. So we're going to have that in the mix as well. So let's put that here. All right, so these are, just put lines between these things just so you can see all the different moving parts. We're going to have the universal quantifier, we're going to have the negation, we're going to have the existential quantifier, we're going to have the disjunction, we're going to have the s predicate, and we're going to have the p predicate. Now what we've got to do is work out how these all fit together in order to provide an adequate translation of the sentence. So in order to do that, I'm just going to get rid of all of this, and we'll get started on actually trying to translate the sentence. So one thing we can do here is rest upon some of the information we had from the previous translation. So in the previous translation we translated out everyone is sailing, and up here we've got that same sentence appearing. We've got everyone is sailing appearing here, so we can do the same translation. That translation, remember, was for all x, if x is a person, then x is sailing. Right? So that gives us a quick and easy way to translate out that first aspect of the sentence. Now we're going to come to the second aspect of the sentence, the someone isn't. What we're going to do is we're going to think about what that means. What that is sort of pointing us to is the fact that there exists a person who doesn't have the property of sailing. So first of all, we want to get the fact that there exists a person. So let's get that out. There exists a person. And we also want to say that they're not sailing. So we're going to put not sx. That gets us, actually, I'll do y. We agreed to use different variables. Okay, that gets us that we've got there's something that has the property of being a person, and we've also got that they're not sailing. We've got to find some way to connect those up. Notice that what we want to do is we want to say that the thing that is a person is also the same thing that's not sailing. So the way that we do that when we're specifying that something stands under two conditions combined is to add in a conjunction from our propositional logic store of items. So that enables us to say there is something such that it's a person and it's not sailing. Someone isn't sailing. Okay, so that's the two sort of big parts of the sentence translated out. We've got the everyone is sailing and we've got the someone isn't. Now what we have to do is we have to put this all together in order to connect it up to make a complete proposition. What we do is we take that unless and we just drop it straight down here and put that between these two sentences and then enclose the entire thing inside brackets like that. All right, and that gets us the complex sentence translated out. We've got everyone is sailing unless someone isn't. So either everyone is sailing or there exists a person who's not sailing. If we want the conditional forms, what we can do is we can transform this into two distinct conditionals. First conditional would be this. So the first conditional is if it's not the case that everyone is sailing, then there exists someone who isn't. And the second conditional is if there doesn't exist someone who isn't sailing, then it follows that everyone is sailing. Okay, so those are the two conditional forms. We don't have the capacity to prove the logical equivalence of these three sentences yet. Later on, we'll have the ability to do that. But in some sense, we don't really need to because we can rest on one of those, some more general results that we had from propositional logic. When we were in propositional logic, we actually proved that these three things are equivalent. Namely, that either A or B is equivalent to if not A, then B, and that's equivalent to if not B, then A. And the broad structure of what we've got here is the same as that basic propositional structure. So we haven't sort of added anything new to the logical structure of what we're doing, and because we're still dealing with the same disjunctive form, we've got the same conversions into the conditional forms. That's one of the nice things about logic, is that often when you prove a basic result in some sort of fairly simple logic or very simple language, that result will ramify up into more complex languages and enable you to sort of make judgments about those languages without having to go into full-blown details already. Okay, that's an aside. Let's focus on this primary translation. We've got everyone is sailing unless someone isn't. So we've successfully translated out the sentence. Let's do another one. Third one, everyone who is not sailing is not juggling. Okay, everyone who is not sailing is not juggling. So how are we going to do that? Let's put this one up. Everyone who is not sailing is not, oops. Start again. Everyone who is not sailing is not. Okay, so there's our sentence. Everyone who is not sailing is not juggling. Again, we start to break it down piece by piece until we've got all our moving parts, and then we put them together. So as in the previous case, we've got an every, so we know that there's a universal involved here somewhere. We've got this one, so we know that there's people involved. Okay. We've got sailing, but we've got not sailing, so we know that there's both a negation and the predicate sailing, so we're going to put the S, and we're going to have the negation in there somewhere. We've also got juggling, so we're just going to add a new predicate J for that, and we've got a not for that as well. So those are the moving parts of what we can sort of see on the surface of the sentence. Now we've got to try and put all those moving parts in order to come up with a sentence and a translation. So we want to say everyone who is not sailing is not juggling. So the first thing we want to do is try and talk about all of the people, because that's what we're doing. We're saying for all of the people, for everything in the universe that's a person, if they're not sailing, then they're not juggling, right? So the very first thing we want to do is focus in on the people. So for all things that are people, right? And then we want to go on to say something about those people. And we use the conditional again to do this. Very basically what the conditional is allowing you to do when you use it in conjunction with the universal quantifier is narrow down the focus of the universal quantifier. So the universal quantifier always wants to talk about the entire universe. So here's the entire universe, everything inside this circle, and the universal quantifier is always like, I want to talk about all of that stuff. And what you have to do is you have to try and rein in the universal quantifier. You've got to try and restrict it so that it's not constantly trying to talk about all of the things in the universe. So maybe you just want to talk about all of the people that are in the universe, right? And they form the sort of proper part of what's in the universe. You want to just sort of focus on those things. And the way to do that is you assign a property to the people, and then you sort of put that property in the back end of a conditional. Because what you end up doing is saying, for all x, if px, which sort of takes that universal quantifier, which is trying to go over everything at once, and then restricts it to focusing on just the things that have the property p, and then you can go on to say something about the things that have the property p that are inside that sort of inner circle. So when we've got this universal quantifier, and we want to talk about people, we start by putting a conditional with the people in the back end of that conditional, because that's going to rein in the quantifier and stop it from trying to range across the entire universe. Now, we actually want to restrict again, because we don't want to just talk about all the people, we want to talk about the people who aren't sailing, and that's going to be some subgroup of this group of people that we've actually identified in the world. So these are the people that aren't sailing. So I'm not sailing right now, I'm in that subgroup. Some of you might be sailing as you're watching this, I doubt it, but if you are, then you're actually outside of this subgroup, you're a person who's sailing. So what we do is we restrict again using another conditional. So that universal is always trying to go big, it's always trying to go big. Even when you restrict it to just the people, it wants to talk about all of the people, it still wants to go as big as it can go. So you have to restrict it again now to the people who aren't sailing. So we restrict it again by using another conditional, this time with the people who aren't sailing in the back end of that conditional. Now what do we want to say about those people? Well, we want to say that they're not juggling. Okay, and that's the final translation. So the final translation is, for all x, if x is a person, then if they're not sailing, then they're not juggling. Everyone who is not sailing is not juggling. For all of the people who aren't sailing, everyone, for all x, if they're a person, then if they're not sailing, it follows that they're not juggling. So everyone who's not sailing is not juggling. Okay, and that's the final translation for this style of sentence. More. Everyone juggles just in case they are coordinated. So here we've got a biconditional in there with the just in case. So we're going to see how to use the biconditional in conjunction with some of the other things that we've got, like the universal quantifier. So everyone juggles just in case they are coordinated. So let's put that up. Everyone juggles just in case they are coordinated. Right, so there's our sentence. Again, we start by breaking it down, working out what the moving parts are, and then trying to put them all back together. We've got this everyone out the front. We know how to deal with that now. We know that we've got to have a universal, and in the scope of that universal, we've got to have some people in order to stop that universal from trying to range over the entire universe. Just wants to focus in on the people. But not just any people, we also want to focus in on the people who juggle. So everyone juggles just in case they are coordinated. So for all the people, those people, for all the things, if they're people, then they juggle just in case they have a particular property. So we also want to look at the juggling, but what we're doing is we're sort of looking at the juggling people and we're trying to say something about the juggling people, namely that if they're a person who juggles, then they have to be coordinated, and if they're a person who's coordinated, then they have to be a juggler as well. So what we do is we add in some moving parts for juggling and coordinating. So we need a JX again for juggling and a CX for coordination. And what we want to say is everyone juggles just in case they're coordinated. So for all X, if they're a person, then they juggle just in case. Remember, the just in case is the biconditional. They are coordinated. All right. So here what we're doing is we're trying to talk about all the people, and then we're specifying a particular condition about those people, namely that there's a kind of standing or falling property with respect to juggling and coordinating. Juggling and coordination go hand in hand. So if you're a person and you juggle, then you have to be coordinated, and the relationship's also coming the other way with respect to the coordinated people juggling. Okay, so this is the translation for this sentence here. Next, if someone is juggling, then everyone is watching. So here we've got some combination of our existential quantifier and our universal quantifier. We've got some juggling, we've got some watching, and we've got to put it all together. So if someone is juggling, then everyone is watching. So if someone is juggling, then everyone is watching. So that's the sentence we're going to translate out now. So what are the moving parts? Well, notice that we've got this big if-then right out the front. And we can, whenever we see that, we deal with it in just the same way that we dealt with it in the propositional logic case. We know that we're dealing with some kind of conditional. So let's put that in first. If someone is juggling, then everyone is watching. So now that we've got a conditional, we've got to work out what's on the left-hand side of that conditional and what's on the right-hand side of that conditional. What moving parts do we have? Well, we've got someone, and we know how to deal with that. So we've got we know we're going to have EXPX. And over here we've got everyone, so we know that on the right-hand side we're going to have for all XPX. Now, what are we saying about the someone? We're saying that the someone is juggling. So we need some way to specify that there is a person who's juggling. How do we do that? Well, we introduce the JX for the juggling, and then we connect with a conjunction. What this says is there is at least one person who juggles. That and enables us to chain those conditions together and specify them of the same thing. Over here, we want to say everyone is watching. We know how to deal with that sort of thing. That's in logical form very, very similar to everyone is sailing, which we've already translated out. It's just that instead of an S, we're going to be using a different propositional letter, a different capital letter, sorry, namely W. So we're going to have for all X, if you're a person, then you're watching. And that's it. That's the translation for this sentence. If someone is juggling, then for all things, if they're people, then they're watching. If someone is juggling, then everyone is watching. All right. Number 6, everything is either black or red. Okay, so now what we're doing is we're using our universal quantifier in collaboration with our disjunction, which is kind of similar to the unless case, but in this situation, we're not even interested in the conditional forms, we're just interested in the disjunctive form. So everything is either black or red. There's our sentence. We've got this everything in there, and notice that we're not talking about everyone. So we don't need to talk about people at this point. And notice that thing is really just wide open. We're not talking about anything in particular. Here, the universal wants to range over the entire universe, and we're going to let it, right? When it says everything is either black or red, it's talking about everything in the entire universe. So let's just let the universal do that, and we're going to leave it completely unconstrained. So we're going to put the universal in, and we're not going to try and constrain it. Now, we want to say that everything is either black or red. So we're going to have to add in 2 predicates. We're going to have one for black and one for red. All right? And now we want to add in our variables that connect up to the universal quantifier here. So that gets us most of the sentence. And we just got to add something in for the either. And we know how to deal with that because we dealt with it in the propositional logic case. The either is this disjunction, which is going to get us this. So for everything in the entire universe, either that thing is black or that thing is red. And notice that this disjunction is the same disjunction we used in propositional logic, so it is of course compatible with this sentence that everything in the universe is both black and red. All right, last but not least, if everything is either black or red, then something is blue. If everything is either black or red, then something is blue. All right, there's our sentence. We know how to handle a lot of what's going on here because it's very similar to the things that we've done so far. So let's go through it quickly. We've got the if-then, so we know that the whole thing is a conditional. On the left-hand side of that conditional, we've got the sentence that we just translated. Everything is either black or red. So we can just put that straight in. For all x, either it's black or it's red. On the right-hand side, we've got something is blue. So we're going to introduce an existential quantifier, and we're going to say that there exists something that's blue. Now for this, because all we're doing is we're just specifying one condition on that thing, we can just drop that straight in front of the existential quantifier in order to complete the sentence. So I've used the predicate L for blue just because it's the second letter in the word blue, but realistically you can use whatever you want so long as you don't reuse B, because that's been uniquely assigned to black in this sentence. Then we put brackets around the whole thing and we've finished the sentence. So if everything is either black or red, then something is blue. Okay, so those are some examples of how to translate out sentences in English using this monadic predicate logic. The language can get quite complicated and translation can be quite difficult using this language, but at the end of the day, you're just doing the same thing that we're doing in these simple examples. What you're doing is you're looking at the moving parts of the sentence, you're looking for some of the logical structure of the sentence, and then you're trying to translate out those moving parts into a complete sentence. So you're going to look for your everyones and your someones to work out where the quantifiers are. You're going to look for your predicates, your things like sailing, personhood, animals, all those sorts of things, so you know where to translate out properties. You're going to look for names in sentence. None of these sentences have names in them, but if you have a sentence with a name in it, you've also got to translate that out. And then you're looking for your propositional connectives, which enable you to concatenate the entire sentence into something that expresses the English thing that you're trying to translate. Okay, as promised, I'm going to now focus on three important things about doing translation in monadic predicate logic, and more general important things about the syntactic structure of the language that are useful to keep in mind. Okay, so the sort of three important points about the quantifiers. The first thing about the quantifiers is that there's an important relationship between the quantifiers that we've looked at. So have a look at this quantifier, right? And the other quantifier, the existential. In our language, these quantifiers are what's called duals of each other. And what that means is that there is a way to translate a universal quantifier into an existential quantifier using a negation and back again, all right? And this respects the way in which we use negation in combination with quantificational statements inside English as well. So this is something we do in everyday language all the time, and the logic is respecting that feature of our English language. So consider this claim. Suppose that I say that everything is blue, all right? Now let's suppose I put a negation out the front. It's not the case that everything is blue. What follows immediately from that? If it's not the case that everything is blue, then it follows that something has got to be not blue. So there has to be something that's not blue, right? These two things say the same thing. If it's not the case that everything is blue, then there's something that's not blue. But similarly, if there's something that's not blue, then it follows that it's not the case that everything is blue. And so this is the first duality between these two propositions. These two propositions are saying the same thing, which means you can move, if you want, from an existential to the universal form, or the universal form to the existential form, in combination with a negation. You have a relationship going the other way. So consider this claim, where we start with the existential and we have B. Here, we're saying there is something that's blue. Let's suppose we put a negation on that. If it's not the case that there's something that's blue, well, then it follows that everything in the universe is not blue. Okay? If there does not exist a single blue thing, then everything in the universe is not blue. And the relationship comes back the other way. If everything in the universe is not blue, then there does not exist a single blue thing. So we have this second duality between the two statements. We can also have, this same duality even when we don't have negations sort of obviously in the picture. So consider for all x, bx. So here I'm saying everything in the universe is blue. Well, what follows from that if everything in the universe is blue? Well, it follows that there does not exist a single thing that's not blue. If everything in the universe is blue, then there does not exist a non-blue thing, which is what that sentence over there says. And coming back the other way, if there does not exist a non-blue thing, then it follows that everything in the universe is blue. So we have another duality between these propositions. Right? So the universal and the existential there can be moved back from one to the other using that negation. Finally, consider this. Something is blue. If something is blue, then it follows that it's not the case that everything in the universe fails to be blue. Right? So if there's some blue thing, then it's just not the case that everything in the universe is not blue, because there's a blue thing, right? Similarly, if it's not the case that everything in the universe is not blue, then there has to be some blue thing. If it's not the case that that the entire universe fails to be blue, then that has to be because there's something in the universe that ends up being blue. And so we have this same relationship. And this is no accident. This is an important feature of monadic predicate logic. It's an important feature of a range of languages that you might deal with in logic, where you have symbols like this that can be intertransformed into each other in order to produce logically equivalent statements. The sort of transformation here allows you to, in principle, remove one of these quantifiers from your language entirely. Because if you look, what you can do is you can actually sort of move, but sort of anything that's existential formed, you can actually translate as a universal form, or anything that's universal formed, you can actually translate as an existential form, so long as you've got that negation with you. And what that means is that you technically only need one of these quantifiers inside your language. You can do everything that you need to do with just one of these quantifiers, so long as you have that negation in there that can operate with the quantifier. We include both quantifiers because it makes the language more elegant. I think it's broadly an aesthetic reason that we use both of these quantifiers. It can make the translations a little bit easier to follow as well. Sometimes it can be quite difficult to just read something with lots of negations in it and a universal or an existential quantifier in there and immediately understand what it's saying. Whereas once you look at the universal form, you can sort of get the statement immediately. So there's a sort of aesthetic reason and I think a comprehension reason why it is that we use both quantifiers. But this duality between the two quantifiers technically renders one of these quantifiers redundant in the sense of being able to translate everything out that we want to translate out in monadic predicate logic. Okay, so on this slide, just for your reference, we've got a statement of all of those duals that you can use. And one thing here to keep in mind is that these duals can actually be quite useful to you when you're performing translation. If you're looking at a translation and the translation is given sort of, in the existential form, you might be able to transform it into the universal form to find a more a translation that is easier to read or easier to understand. Indeed, you might have a question in tests or assignments or exams where you'll have the question asking for one of the forms, but all of the answers being translated into the other form, and you have to sort of do the back translation. And that's in order to give you a sense of how these quantifiers actually relate to one another. Okay, the second thing, and this is quite important, is this notion of quantifier scope. So far I've talked about scope and I've used scope in the context of doing these translations, but I haven't told you exactly how it works. Here's the basic idea. The scope of a quantifier is the well-formed formulae that the quantifier ranges over. So these are the things that quantifier is, if you like, operating upon. So to get a sense of how the scope of these quantifiers might vary, it's useful to have a look at these two different propositions. So I've put have a look at the first proposition. We've got for all x, rx, arrow, ex, px, and tx. All right. Now, notice with this sentence, I've actually violated one of the things that I said earlier, which is that when you add more quantifiers, you actually add more variables. the third important thing I'm going to tell you about quantifiers is how that works. For now, just go with the flow and we'll just look at this notion of quantifier scope. It's easier to sort of explain the notion of quantifier scope when you're using the same variable all the way through. So just sort of keep that in mind as we proceed. Okay, so the scope of a quantifier is the thing that the quantifier operates on. So when I say everyone is sailing, the quantifier, everyone, is operating on people and it's saying about those people that they're sailing, right? So that's the notion of scope that we're interested in. And we're trying to work out how to determine the scope of a quantifier when we're actually translating out a sentence or looking at a sentence in monadic predicate logic. So if we look here, we've got two quantifiers. We've got this universal quantifier and we've got this existential quantifier. And the scope of the quantifier is the well-formed formula that the quantifier ranges over, and it's typically the formula that immediately follows to the right of that quantifier. So here we've got the universal quantifier, and you've got that Rx immediately following the universal quantifier, so that Rx is in the scope of that universal quantifier. Over here we've got that Px and that Tx immediately following the existential quantifier, and so that Px and Tx is in the scope of the existential quantifier. But what's really important is that what happens over here is quite different to what happens over here. The two things don't quite relate to each other with respect to scope. So the Px and the Tx are in the scope of this existential quantifier, but they're not inside the scope of that universal quantifier. That universal quantifier sort of has its scope soaked up as soon as the end of that Rx occurs. Over here, and like the same story works in reverse. When you've when you're looking at the scope of this universal quantifier, this Px and Tx are not in the scope of that, but similarly this Rx is not in the scope of this existential quantifier over here. This Rx falls within the scope of this universal, but it doesn't fall within the scope of the existential. So what that means is that this existential here is talking about these propositional letters here, but it's not talking about this propositional letter here. The universal quantifier is talking about this propositional letter here, but it's not talking about these letters over here. So scope can vary, and the way to vary the scope of things is to mess around with the brackets. So let's have a look at a couple of different sentences that have different scopes so you can get a feel for how this works. So let's have a look at this. So this is basically the sentence I was just putting up. Oops. All right, so we're trying to work out the scope of the quantifiers here, and we look to see where the brackets lie. So that's the key thing when you're trying to work out scope. You're trying to look for the brackets that immediately follow the quantifier, and anything that falls within those brackets, it lies within the scope of the quantifier and nothing else does. So over here we see this universal quantifier, and we can imagine that there are brackets immediately following it. We sort of omit those brackets when we've just got a single proposition. So when you've just got a single proposition following a quantifier, the scope is just exhausted by that single proposition. So over here, the scope of the quantifier is this Rx, and because there's no brackets sort of around this Rx and the rest of the sentence, the scope of that quantifier is limited to the Rx. Over here, when we look at the existential quantifier, we see those brackets around the entire Px and Tx, and so that makes the Px and Tx fall within the scope of the existential quantifier. So the two quantifiers here have different scope. The universal quantifier has that scope around the Rx, and the existential quantifier has that scope around the Px and the Tx. And notice that nothing has scope over the entire sentence because there's nothing outside these brackets here. In order to get something have scope outside over the entire sentence, we'd have to put something outside the brackets here. Now, one thing that's important about scope is that the sort of variables that you are reading along the sentence, they sort of glom on to the first quantifier that they meet, reading from right to left. So as we're reading from right to left, we see the x and the px, and they first meet this existential quantifier, and so they lock onto that existential quantifier, and then that's it, they're done. That's their scope exhausted. And as we move over, this Rx locks onto that universal quantifier because that's the first quantifier that it meets, and then they're done. That exhausts their scope. So long as the variables agree between the quantifier and the sentence that you're interested in, the scope of the sentence will get exhausted by the first quantifier that it meets. So it gets sort of sucked up by the quantifier as soon as it hits it going from right to left. Okay, let's look at a slightly different case. Have a look at this one. Okay, so in this case, we've got a slightly different situation with respect to scope. The py and the ty here are all within the scope of this existential quantifier. And this rx is also within the scope of this universal quantifier. So that's the same as in the previous case. But in this case, it turns out that everything inside the brackets here is actually also within the scope of this universal quantifier. So what I said a moment ago, that the scope gets sort of soaked up by the first proposition that it meets, is not quite right. Because what we have to do is we actually have to differentiate between the scope of a quantifier and what the quantifier is bound to. And I'll be talking about binding in a moment. But when we're talking about binding, that's the thing that's really going to get soaked up as we move from right to left, whereas scope can sort of outrun the way that binding works. So if we look here, we see that these y's are bound to this existential quantifier, which is to say that that existential quantifier operates on those y's and it tells those y's how to work. And that binding gets soaked up as soon as we meet that existential quantifier. So these y's can't be bound to anything else because they get bound to the first quantifier that they meet. Over here, this x also gets bound to the first quantifier it meets, reading from right to left. So the binding story is that same story from right to left. But the scope here is slightly different. Technically, these quantifiers, this quantified sentence is within the scope of this universally quantified sentence without those variables being bound to that universal quantifier. So you can have sentences within the scope without being bound to it. So what the scope means is that ultimately, in order to work out the truth value of everything that's going on in here, we have to look at the thing that governs the scope of the entire sentence. Here, that universal quantifier governs the scope of the whole thing, so we're actually looking at an entire sentence that is operated upon by a universal quantifier, and that's the thing that we're going to have to focus on. Up here, the scope of this universal quantifier is this Rx, the scope of this existential quantifier is this Px and this Tx, and there's nothing that has broad scope over the whole thing, which means that we're not sort of operating on the entire sentence using a quantifier like we are here. This will make more sense once we actually start to dig into the semantics and we can see what difference it makes when you alter the scope of a quantifier. Because right now, because we don't have an interpretation of these symbols, we don't really know what they mean yet, it can be somewhat difficult to understand how the scope of a quantifier is shifting as we move from this sentence to this sentence. But sort of, for now, the take-home message is something like the following. The scope of a quantifier is determined by the quantifier that's right, by the brackets that the quantifier has immediately following it. So here, that universal quantifier has those broad set of brackets following it, and so that's the scope of that entire universal quantifier. The scope of this existential quantifier is this set of brackets. So if you want to know what the scope is, you just got to look for the brackets that follow the quantifier. If there are no brackets following the quantifier, if it's just attached to a basic proposition, then that's its scope. And scope, the sort of second take-home message here, scope is different to binding, what it is that actually, the way in which the variables inside the sentence connect up to the quantifier. So to make the distinction between the binding of a sentence and the scope of a sentence a little bit clearer, let's have a look at what it is for a variable to be bound or unbound inside our language. So inside monadic predicate logic, we actually have a distinction between bound and unbound variables. And a bound variable is any variable that sort of sits completely within the scope of some quantifier or other. So have a look at this. We've got this for all x, we've got this Rx. Now, as I said before, the scope of the quantifier, when you've just got one proposition following it, one basic proposition, is going to be exhausted by that basic proposition. When you've got some brackets, it's going to be whatever's in the brackets, but let's just focus on this simple case for now. That variable there is inside the scope of the universal quantifier, and what that means is that that variable gets bound to that quantifier, which means that that's the thing that this universal quantifier is talking about, right? So if this is the property of rowing, and I want to say that I also want to talk about purple things, then what I end up saying here is that everything in the universe is rowing and purple, where I sort of put both the rowing and the purple into the service of the same quantifier. And that's what binding to the quantifier means. When the variables are bound to the quantifier, they're in the service of that quantifier, they're the thing that that quantifier is talking about. So in this sentence, all of the variables are bound. There's no sentence in here which isn't connected to some quantifier or other. The syntax of monadic predicate logic actually permits there to be unbound variables. So have a look at this sentence. The key to binding is that the same type of variable binds to the same type. So x's bind to x's and y's bind to y's, but x's never bind to y's and y's never bind to x's. You always have to have the same variable. So if we have a look here, this py is within the scope of this universal quantifier because it falls within the brackets that immediately follow the quantifier, but this y is not bound to that quantifier because it's not the right variable type. This x over here is bound to this quantifier. So what this means is we've got a sentence where we have an unbound variable, and we can have that. That's permitted by the syntax. There's nothing grammatically ill-formed here. But what's happened is that we've said something that is not a proposition. As we'll see when we do the semantics, there's no way for this thing here to be true or false. We actually just don't have adequate systems to understand the truth or falsity of a case in which you've got an unbound variable. What that means, which is sort of fortunate for us in this course, is that we're just going to basically ignore the existence of these things inside our language. So although our language can express these unbound variable cases, we're only going to focus on the cases where every variable is bound to some quantifier or other. Okay. There's another important feature of binding with respect to variables, and this important feature relates to that notion I was talking about before, which I first introduced as scope, but which then I said isn't really about scope, it's about something different, it's about binding, and that's this notion of soaking up the variables as you move from right to left. So this soaking up is really a concept to do with binding, and what the binding sort of does when you're thinking about universal propositions or existential propositions is the variable that matches the type of the quantifier, reading from right to left, will bind to the first quantifier it meets and no other. So if you have a look at this sentence, now we're going to read the sentence from right to left. Reading from right to left, this x will bind to this x, but it won't bind to anything else. So what that means is if I have another quantifier out the front here like that, then this x is not going to bind to that y. It won't bind to that y because it's a y as well, but it's also not going to bind to that y because even if it could bind to y's, its binding power has been soaked up by meeting that first universal quantifier. Now, what this means is that you can have cases like this. All right? So we can put these three universal quantifiers like this, and then we can have some sentence following the universal quantifier. Now the scope of this universal quantifier here is everything inside these brackets, and in fact, as we move outwards, the sort of outwardmost quantifier has everything here within its scope. We're not going to see cases like this, and so we don't need to worry too much about trying to understand how scope works in this case. What matters is that we understand how the binding works. And what's going to happen is that the x's inside this sentence are going to bind to the first quantifier they meet, they're going to bind to this one, and then they're not going to bind to the rest. So those quantifiers out the front are they're actually not going to bind to anything, which means that those two variables are going to be unbound in this sentence, whereas all of these three variables are perfectly well bound. The fact that what this sort of means is that we can reuse the same variable repeatedly, because once the sort of variable gets its binding soaked up by the first universal or first existential quantifier it meets, we can then reintroduce that same variable and it turns out to be a distinct variable. So have a look at this. Suppose that I've got this sentence. So in this sentence, I'm reusing that x, which is something that I was doing previously when I was talking to you about scope. But now what we're doing is we're thinking about binding, and you might have thought we can't use the same variable throughout here because that's going to be confusing or something like that. But actually, everything is going to behave perfectly well, because what happens is that these x's here bind to the first quantifier they meet, and then that's it. They don't bind to anything else. They're done. They can't bind to this existential over here. This bx binds to this first quantifier that meets, moving from right to left, so it binds to that existential, and then it's done. And moreover, it can't bind in the opposite direction, so it can't bind from left to right. So what we really have here are two different variables that we're drawing the same symbol for. The first variable is the one that's that's bound to this universal quantifier, and the second variable is the one that's bound to this existential quantifier. They're talking about different things. We've used the same symbol, but as long as the binding operates adequately and it's set up in this language to do so, we're not going to end up with any problems arising from the use of the same variable repeatedly. That said, we do typically tend to use different variables every time we introduce a new quantifier, and the reasons for this are similar to the reasons that we use two quantifiers at all rather than using one quantifier and then just operate on it with a negation. The reasons that we typically introduce a new variable each time is that on the one hand it's more elegant, it seems more aesthetically pleasing to do it this way, and on the other hand it's easier to read. So comprehension is increased because you're not trying to, as soon as you see all these x's, you don't have to sit down, you have to sit down and sort of work out what's bound to what, work out where the scope lies and all that kind of stuff. But when you've got different variables, you can just see immediately what's bound to what and know, and whether or not anything is unbound, and thus you can sort of get a very clear sense of what the sentence is saying without having to think too hard about it. Okay, so that brings us to the end of the syntax for monadic predicate logic. So just to recap the important points about the syntax for monadic predicate logic, we've looked at the just do a summary slide of these important points. We've looked at the actual components of the monadic predicate logic, and the components of these, we've got the universal, we've got the existential, we've got the sorry, let me start that again. We've got the universal, we've got the existential, we've got the predicate letters, and we've got the names, and we've got the variables. So we've got all of those components. And then we've got the and, the or, the biconditional, the conditional, and the negation. So we've got those components as well. Some key points about the language. One, you've got to be careful about the scope. And the scope is whatever, scope equals brackets, right? So you look at where the brackets lie with respect to the universal or existential quantifier, and the scope of a quantifier is going to be whatever lies within the brackets immediately following that quantifier. We've got to be careful about binding. So the binding is going to be right to left, and it's the first universal or existential that you meet, right? So we bind from right to left when we're reading the sentence, and the variables bind to the first quantifier that they meet. We also need to remember that the universal always wants to go big, and so we have to restrict that universal down using the arrow in order to say meaningful things in the language. And the last thing is that we've got quantifier duals. So the universal and the existential can transform via the negation. And so those are the sort of core points that I want you to take away from understanding the syntax of monadic predicate logic. As with a lot of the things that we've discussed so far in this course, the only way to get proficient here is to do some examples, and that's no truer than when you're dealing with translations. Translations can be hard to get your head around, but the key thing is to just do a lot of them and to take them slowly, piece by piece. Remember that this language is compositional. It's built up from smaller pieces. English is also compositional. It's built up from smaller pieces. And so what you can do is you can break both of them down to their smallest parts, and then once you've got those smallest parts, build up the logic to get the built-up version of the English sentence. So just take it slowly and don't look at a sentence and sort of get worried because it seems really complex. All you have to do is just break it up into its smallest parts and then chain those together in order to get the right kind of translation out at the end. But ultimately, it's just a matter of practice in order to nail down doing these sorts of translations. All right, up next, we're going to do the semantics for the language. So I'm going to tell you what all of these squiggles mean so that you can actually understand it. And that's going to move us towards coming back to concepts of validity, which we're going to have to redefine in light of the new semantics for this kind of language. And then ultimately, we're going to come back to proofs, and we're going to dial up the complexity of our truth tree system so that we can prove things inside this new language. All right, until then, I hope that you enjoy practicing some of these translations and that you get a chance to work through some of the more complex cases where you're using sort of multiple quantifiers and multiple connectors in order to get a really clear sense of how this all works. All right, thank you very much.